Good morning, one and all. You are welcome in Sanjeevanee Mahavidyalaya Chapoli, which is affiliated to Swami Ramananda Marathwada University, Nanded. I thank Honorable Principal for giving me such a chance to give the knowledge to the students online. This lecture is again for B.Sc Physics TY students, paper number 13A. Again, I'll revise in short what we have studied and what we are going to study now. We have studied about the law method for the study of crystal structure, how law method is utilized. In the same way, how one more method is there, how it is to be used for the study of crystals. This method is said to be rotating crystal method. So before that, we are going to discuss some uses of X-ray diffraction and advantages also. The uses of X-ray diffraction. X-ray diffractions are used to distinguish crystalline and amorphous materials, to study the structure of crystalline substances, to determine the distribution of electrons within the atoms throughout the unit shape. It can be used for the determination of the orientation of the single crystals. It is also used for the determination of texture of the polygrain materials. It is also useful to measure the strain and the small size of the material. The X-ray diffractions are very useful for the characterization of the materials, such as phase analysis, lattice parameter determination, strain determination, texture and orientation analysis, order disorders transformation, and many more things are there. So what are the advantages of X-ray diffractions? X-rays are very less expensive. We say least expensive. This is most important advantage of X-ray. The most convenient and widely used method to determine the crystal structures. They are most convenient. Next one is X-rays cannot be observed by ear, so that crystal can be mounted openly. There is no need to mount the crystal in evaporated chamber. Now let's turn towards disadvantage. Has advantages, but there are some disadvantages. What? X-rays do not interact very strongly with lighter elements. Those elements which are lighter, on that they can't interact very strong. So there are three types of X-ray photographs: law photograph, rotating crystal photograph, and powder photograph. So we are discussing important method, which already I have told you, that is rotating crystal method. In rotating crystal method, here X-ray source is used to incident the X-ray beam on the crystal. The crystal is mounted where? It is mounted on the shaft. I will show you figure so that you will get an idea. Here X-ray source is there, crystal is placed on in the cylindrical camera. Here I will show you X-rays are shown here. They are passing through collimator system to make the X-ray monochromatic. Diffracted rays. This is the photographic plate. Here shaft is rotated. Crystal is placed on the or mounted on the shaft, and there is arrangement of rotating by using motor. In rotation method, a single crystal is placed perpendicular to the X-ray beam so as to intercept all X-ray diffracted by a strongly crystal or rotating crystal. The crystal is rotated through an angle of 2 to 4 degrees, and all resulting diffraction maxima are recorded on the film. Here I will show you figure so that you will get idea. This is the X-ray tube. X-rays are produced here in this X-ray tube. Here cathode is there. Whenever heater is used to heat the cathode emit electrons, and these electrons they strike the anode, and here X-rays are produced. Main part is this. Here X-ray produced, and they are allowed to pass through monochromator, and they are allowed to pass through the collimator to make it what? Monochromatic. Monochromatic in the sense single wavelength. X-ray is having single wave. So the beam of X-ray is incident on this crystal, single crystal, which is mounted on the stand, or we can say mounted on the shaft, which is connected to the spindle or which is connected to the motor. And here cylindrical camera is fitted here inside this cylindric photographic camera. Single crystal is mounted. So this is about the basic diagram of rotating crystal method. X-ray is generated in X-ray tube and X-ray beam is made monochromatic. It means having single wavelength. Now, rotating crystal methods. In rotating crystal method, if we use a single crystal is mounted within rotating axis perpendicular to the monochromatic X-ray, then we will obtain such a various spots on this film. A cylindrical film is placed around it and the crystal is rotated on, or a detector is rotated. Shades of lattice planes will at some point make the correct Bragg's angle. You know Bragg's law. Reflection and diffraction takes place whenever Bragg's law holds true, that is 2d sin theta is equal to n lambda. Then only diffraction and reflection takes place, and we will obtain various such type of images. So the spots are observed on this photographic. Here in rotating crystal method, a single crystal is mounted again with an axis normal, perpendicular to the monochromatic X-ray beam. A cylindrical film is placed around it and the crystal is rotated about the chosen axis. As the crystal rotates, shades of lattice planes will at some point make the correct Bragg's angle for the monochromatic incident beam. And at that point, a diffracted ray or diffracted beam will be formed. And because of the diffracted beam, we will get its image on the photographic film. And using this relation, that is d is equal to a upon root this formula, we can obtain this d also. The lattice constant of the crystal can be determined. This is lattice constant. With the help of this method, for an angle and for a given wavelength lambda, if the angle theta which a reflection occurs is known, and d will be determined by using Bragg's law. That is 2d sin theta is equal to n lambda. See here, X-ray generated in X-ray tube. X-ray generated in X-ray tube and they are made monochromatic by using this collimator and monochromator arrangement. Monochromatic radiations will fall on the crystal which is mounted on the shaft as shown in figure. Here it is shaft, rotating shaft. Here crystal is mounted. Such a monochromatic beam of X-ray is incident on this crystal which is mounted on the shaft. Then what happens? This shaft will be rotated with angular uniform motion using spindle fitted with a motor. So in angular uniform motion, purpose is what? The shaft will rotate the crystal at a slow rate, and because of this constant and slow rate, what happens? We will get, it will cause set of planes coming one by one successively into their reflecting positions. And whenever it will follow Bragg's condition, reflection and diffraction occurs. Each plane will produce a spot inside the photographic film inside the camera. The photographic film is fixed perpendicular to the incident X-ray beam inside the camera. You see now here, X-ray beam is parallel to the plane here. I have shown here 1, 2, 3 planes. These are the 3 planes. They are parallel to each other, and these X-rays, I mean incident X-ray beams, they are also parallel to each other. They are parallel to each other, and they are parallel to what? These planes. Means there is no reflection and diffraction with these surfaces because they are at what? 0 degree. They are what? At 0 degree. There is no 90 degree. They are parallel to each other. So there we obtain 4 dots on the screen, on the photographic film. Here, this causes a set of planes coming successively into their reflecting positions because of its slow rotations. When your bright conditions satisfy, reflection and diffraction occurs. Each plane will produce a spot inside the photographic film in the camera. The photographic film is fixed perpendicular to this. There are 2 methods again for the study of crystal. Number 1 is complete rotation. In this complete rotation method, the spindle, or we say crystal, is rotated through 360 degrees Celsius with slow rate. And each plane diffracts 4 times during a rotation. These 4 beams are distributed in the form of rectangular pattern. And second one is oscillation. In this method, crystal is rotated, no doubt. But how it is rotated? It is rotated through an angle of 15 degree to 20 degree. And the photographic plate is also rotated through the same degree, that is 15 degree to 20 degree. And we will obtain their Bragg's condition, that is 2d sin theta is equals to what? N lambda. By obtaining Bragg condition, we will get their reflection and diffractions, and we obtain the various spots on the photographic film. So like this. Like this, various spots we will get. So this method is useful. In this way, this method is useful for the study of structure of a crystal, for getting the parameters of the crystal. In order to get lattice constant, this method is also very useful. See now, X-rays are here source. It is given a set of plane crystal diffracts 4 times during the rotation, which already I have told you. And we will obtain 4 diffracted beams are distributed into a rectangular pattern in the central point of the photograph. Oscillation method, crystal is oscillated through what? Through an angle of 15 to 20 degrees Celsius. At the same time, the photographic film or photographic plate is also moved or rotated through same degree Celsius. The position of the spot on the plate indicates the orientation of the crystal at which the spot is formed or spot was formed. So in this way, by observing the photographic plate, we can analyze the nature of the crystal. We can analyze all these things, that is phase analysis, lattice parameters, strain determination, etc. we can obtain using this, that is rotating crystal method. Thank you.